Hi students, this is Alex here. In this video, we have a problem in which it is given the ends A and B of a rod 30 centimeter long kept at 20 degrees centigrade and 80 degrees centigrade respectively until steady state condition prevails. Then the temperature at B suddenly reduced to 60 and end A is raised to 40. Find the temperature distribution U of x comma t. Let's take a small diagram. We have a rod of length 30 centimeter and one end is A and other end is B, and here initially it is at 20 degrees centigrade and this is at 80 degrees centigrade. Then the temperature at B suddenly reduced, so this is reduced to 60 degrees centigrade and here it is increased to 40 degrees centigrade. Now we have to find the temperature distribution U of x comma t. Now the heat equation is dou U by dou T equal to alpha square dou square U by dou x square. And since there is a steady state condition, and in steady state condition dou U by dou T becomes 0. If I substitute this term will become 0, that is dou square U by dou x square becomes 0, and on integration and solving this we get U as ax plus b as the solution. Now we are going to write the boundary and the initial condition. The boundary and initial conditions are, first one, U of x comma 0, that is when time is 0, actually U of 0 comma t, because at the end A x is 0, at any time t we have 20 degrees centigrade, so we take this as 20, and for all t greater than or equal to 0, or we can say it is t greater than 0 or greater than or equal to 0. Then condition 2 is U of 30 comma t, that is the other end, because the rod length is 30 and the temperature here is 80, so we can say this is 80, and for all t greater than or equal to 0. And third one, we have to find U of x comma 0. When t is 0, we need U of x. So for that we are going to take this condition and this solution. U is ax plus b. So when x is 0, U equal to ax plus b. When x is 0, we get U as, in the starting at A we have 20 degree. So U is 20. So 20 equal to A into 0 plus B. So B is 20 actually. Similarly, when x is 30 and U is 80 at the end B, so we have written it here. Using this, U equal to A into x is 30 plus B, just now we got, and even this U we can substitute as 80 itself because we have that as a condition. So now this is 80 minus 20 equal to A into 30. So it is 60 by 30 is A. So A is 2. Now after getting A and B, we have our solution U, which is U equal to AX. So 2x plus B, which is 20. So here this is 2x plus 20. Now we are going to write the suitable solution for the heat equation. The suitable solution is U of x comma t is A cos px plus B sin px e power minus alpha square p square t. Now using the first boundary and the initial condition, which is u of 0 comma t is 20. So wherever x is there, I have to substitute 0. So u of 0 comma t becomes a into cos 0 is 1, sin 0 is 0. So we have only a e power minus alpha square p square t. And this value is 20. So 20 equal to a e power minus alpha square p square t. Again, we are going to use the second condition in the solution. So using second condition, which is u of 30 comma t is 80. So wherever x is there, I have to put 30, the value of L at end B. So u of 30 comma t is a into cos p into 30 plus b into sin p 30. So we substituted x as 30, e power minus alpha square p square t. Now it is difficult or not possible to solve these two, because the other side we have a constant. Let's replace a constant, that is this 80. We have to replace this 80 here. So we already have one equation. After replacing 80, 80 equal to a cos p 30 plus b sin p 30 into e power minus alpha square p square t. So it is not possible to solve these two equations to get the constants a and b. So that we have to clearly specify. So it is not possible to solve the above equations to get the constants a and b. So we are going to split our solution u of x comma t as two part. One is steady state, which depends only on s. So u s of x, and transient state u t of x comma t. Now we are going to write the initial and the boundary condition for u s of x. So the initial and boundary conditions. Now u s of at 0. So this is the first condition, and here we notice that the temperature is at A is increased to 40, at B it is decreased to 60. So at x is 0, it is at end A, it is 40 degrees centigrade, and u s of 30 will be 60 degrees centigrade. And third one, u s, let's take it as ax plus b. It is, that is u s of x. Now we know when x is 0, u s become 40. So when I put 40 here, 40 equal to a into 0 plus b. From this, value of b is 40. Similarly, when x is 30, we get us is 60. So this will become 60 equal to a into 30 plus b, which is 40. We're going to subtract this. So 60 minus 40 equal to a into 30. That by 30 I can write it here. So it is 20 by 30, which is actually 2 by 3. So this us of x becomes 2 by 3x plus b is 40. Now we are going to take ut of x comma t from this equation. That is ut of x comma t is u of x comma t minus us of x. Now let's write the first condition. That is ut of 0 comma t. This will become u of 0 comma t minus us of 0. And u of 0 comma t, we have to find separately. That is, u of x comma t is subsequent temperature function. So when I have u of 0 comma t, this becomes later, subsequently this temperature is reduced to 40 and 60 at A and B. That is, sorry, increased to 40 and decreased to 60 at A and B respectively. So this becomes 40. So I am going to use it here. 40 minus us of 0 already we found, that is also 40. So after subtraction, ut of 0 comma t becomes 0. Now condition 2, ut of 30 comma t, this also u of 30 comma t minus us of 30, and u of 30 comma t is, it is a subsequent temperature at B, which is 60 degree. So this is 60 minus, when I substitute here, ut of 30 comma t, this is 60 minus us of 30, that is also 60. So we get 60 minus 60, that is also 0. Now coming to the third condition, ut of x comma 0, this will be u of x comma 0 minus us of x. And now u of x comma 0, let us take it as the function which we already got here. So it is 2x plus 20. 2x plus 20 minus us of x, we have it here, 2 by 3x plus 40. 2 by 3x plus 40. Now this is 2x plus 20 minus 2 by 3x minus 40. So we can combine the x terms by taking LCM. LCM is 3. So 3 to 6, 6 minus 2, 4. So 4x by 3x, and by subtraction of this we get minus 20. So we got three conditions. Actually this is ut of x comma 0 because we have substituted this value and this value here directly. So ut of x comma 0 is this. So we have three conditions now. Now let's write the suitable solution. The suitable solution is ut of x comma t is a cos px plus b sin px into e power minus alpha square p square t. Now using the first condition, ut of x comma 0. So here we have ut of 0 comma t, which is ut of 0 comma t is 0. ut of 0 comma t. So we are going to use the first condition, and this is 0. So wherever x is there, I have to put 0 because it is at the end a. So ut of 0 comma t becomes a into cos 0 is 1, sin 0 is 0. So we have only a, e power minus alpha square p square t, and this value is 0. So totally 0 equal to a e power minus alpha square p square t. From this, e power minus alpha square p square t cannot be 0 because it exists for all the values of t. Therefore, the only option is a becomes 0. So we're going to use a as 0 in our solution. Using a0 in our solution, we get ut of x comma t become, when a is 0, we have only b term, b sin px into e power minus alpha square p square t. And we are going to use the second condition. So using the second condition, ut of 30 comma t is, what is the condition? So here we have, that is also 0. So wherever we have x, we have to substitute 30. So ut of 30 comma t is b sin p into 30 e power minus alpha square p square t. And this is 0 now. So 0 equal to b sin p into 30 e power minus alpha square p square t. Here b not equal to 0 since a already 0, and e power minus alpha square p square t also not equal to 0. Therefore the only option left is sin p 30 equal to 0. Whenever sin theta is 0, theta is equal to n pi. So p 30 equal to n pi, p is n pi by 30. So we are going to substitute this ut of x comma t. So b into sin px. So this is p and x e power minus alpha square p square, which is n square pi square by 30 square into t. Now this is ut of x comma t is summation n is from 1 to infinity bn sin n pi by 30x e power minus alpha square n square pi square by 30 square into t. Now we are going to use third condition. Using the third condition, ut of x comma 0, that becomes this 4x by 3. Actually it is only 4x. So this x no need. 4x by 3 minus 20. So we write it here, 4x by 3 minus 20. So wherever t is there, we have to substitute 0. So when t is 0, this becomes ut of x comma 0 equal to summation n is from 1 to infinity bn sin n pi by 30x e power 0 is 1. We have left only this much, and this is the half range Fourier sine series. Before that, let's write the function on the other side, which is 4x by 3 minus 20 equal to summation n is from 1 to infinity bn sin n pi by 30x. So this is half range Fourier sine series. So we can find the constant bn using the integral formula 2 by L integral 0 to L f of x into sin n pi x by L dx. So this will become 2 by 30, 0 to 30, f of x is 4x by 3 minus 20 into sin n pi x by 30 dx. Now using Bernoulli's formula, this is u and this is v. U is 4x by 3 minus 20 and v is sin n pi x by 30. U dash becomes 4 by 3, u double dash becomes 0. And v1, its integration minus cos n pi x by 30 by n pi by 30. And v2, its further integration minus sin n pi by 30 x by n pi by 30 whole square. Now this is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So this bn equal to 2 by 30 u, which is 4x by 3 minus 20 into v1, which is minus cos n pi by 30x by n pi by 30 minus u dash, which is 4 by 3 into v2 minus sin n pi by 30 by n pi by 30 whole square, and our limit is from 0 to 30. Now let's apply the upper limit 30 wherever x is there, and here x will come. So we have to apply 30 in all these places. So when I apply the upper limit, outside we have 2 by 30. This will become 4 into 30 by 3. Then minus 1 into, when I put 30 here, 30 gets cancelled, cos n pi, which is minus 1 whole power n divided by n pi by 30. When I put 30 here, we get, after cancelling 30, sin n pi, which is 0. So we have only this much, minus, when I apply the lower limit 0 here, we get minus 20 into cos 0 is 1, already there is a minus 1. So by n pi by 30, and this term will not be there because sin 0 is 0. So we have only this much left. So finally 2 by 30, we can cancel this. So 40 minus 20 is 20. There is a minus sign and there is a minus 1 whole power n, and here we can cancel this. This is minus 20, and we can have a common denominator n pi by 30. The 30 I can take to the numerator. So we can cancel this. So now we can take the minus 20 outside common. So 2 into minus 20. After that we have minus 1 whole power n, then plus 1, because minus 20 we have taken common, divided by n pi. So this bn is minus 40 by n pi, and we have minus 1 whole power n plus 1. And here we can take two set of values. If n is odd, like 1, 3, 5, so minus 1 whole power 1 plus 1 become minus 1 plus 1, it becomes 0. So this is 0 when n is odd, and when n is even, like 2, 4, 6, the term minus 1 whole power 2 plus 1 becomes 1 plus 1, which is 2. Already there is minus 40, so into 2 is minus 80. So this will become minus 80 by n pi when n is even. So this is the value of bn. So we have two set of values for bn. So when I substitute in u t of x comma t, we have summation n is from 1 to infinity, but now it is even till infinity. Bn is minus 80 by n pi into sin n pi by 30x e power minus alpha square n square pi square by 30 square into t. So finally our solution u of x comma t is made up of two parts, that is u of x comma t is u s of x plus u t of x comma t, and u s of x already we got, which is here, that is 2x by 3 plus 40. So we can substitute that here, 2x by 3 plus 40, and here we can take the common, the constants outside the summation, and so already minus is there, so we can take minus 80 by pi, and we can now write the summation, which is from even till infinity. We left with 1 by n, then sin n pi by 30x e power minus alpha square n square pi square by 30 square, which is 900 into t. And we can change this even to 1 to infinity by replacing n as 2n. So this becomes 2x by 3 plus 40 minus 80 by pi. Now summation n is from 1 to infinity. Every n is replaced as 2n. So all the n's are replaced as 2n. So this will become 1 by 2n sine 2n pi by 30x e power minus alpha square 2n whole square. Then we have pi square by 900 into t. We can cancel this 2 and this, it becomes 40. So it is 2x by 3 plus 40 minus 40 by pi. Summation n is from 1 to infinity. We have 1 by n sine. We can cancel this also. So it become 15. So sine n pi x by 15 e power minus alpha square. When I square this, this will become 4n square, and the 4 and 900 we can cancel. It will become 225 in the denominator. So alpha square n square pi square by 225t, because this will become 4n square by squaring. Then we have 900. So 4 and 900 cancel and get 1 by 225. So this is our final solution u of x comma t for the given problem. So this is the complete solution we have.